Hi there guys, in this video we're going to have a look at how to solve trig equations again, but with a change of range, which is actually when it starts to get tricky, and some other different style of questions. We're going to start with that other different style, because quite often you get questions like this. So we're given a cos ratio is a minus value, and that theta is reflex, and we've got to find the value of sine theta. So I think I'll probably just do one of these, because they're both, wow, let's do both, we'll see how we go. But what we know is from here cos theta is negative. So if we draw a cast diagram, well, they're all positive there and cos is only positive here. So cos theta would only give negative values in these two quadrants, S and T. But the fact that the angle is reflex, if we were to stop in this quadrant, we'd have an obtuse angle. So anything past the 180 mark is reflex. So even in this quadrant it's reflex, but cosine of values would be positive, not negative. So we know that's what we're dealing with. And we're asked to find the value of sine. So all I can tell you at the moment is that sine theta is also negative, because only tan is negative. Only tan is positive. So let's do both actually. Let's just do both so that I don't have to do the other question. Right, but tan we know is going to be positive. Now, what I like to do with these questions is just go back to the understanding of the ratio. So with a cosine ratio, that's always in a right angle triangle, remember. And if that's theta, doesn't matter where I put theta, we know that this 3 over 5 is the adjacent over the hypotenuse. Now with a triangle, there's no need to understand or think about the negatives because they don't physically exist. And you should understand by now the symmetry of these. We're going to get the same results whether it's positive or negative in the cast diagram anyway. So to use a sine ratio, what I need is the opposite in the hypotenuse, and use the tan ratio, I need the opposite in the adjacent. So we just need to work this out. So hopefully you can see this is the 3, 4, 5 Pythagorean triple. So the sine, and can you see in this question it says exact value? So this is what it should really say here. You don't need your calculator for this. So the sine is the opposite over hypotenuse, so it's 4 over 5, but we know all the tan ratios are going to give a negative output. So the tan ratio is the opposite over the adjacent, TOA, so that's just going to be 4 over 3. I'll do a little bit on B, so if we just make that small, so just so I can explain the car. Oh, not everything. Can I just take that bit? Yes, I can. Right. So I'll change the colour as well so you can see it. If we draw a cast diagram, so this time we can see sine is positive. Now if they say obtuse, it tells us which quadrant. If it was acute, it would be in here, but we've had to go into this to create an obtuse angle. So what do we know about cosine? Cosine of, I'm just trying to change this to a theta, is negative because only sine's positive. Oh, let's just do it. Right, so the sine of an angle is opposite over hypotenuse, that's 2/5. 25 take away 4 is 21, so this is the square root of 21. The adjacent over hypotenuse, so that's root 21 over 5, and there you go. Adjacent over hypotenuse. It's as easy as that. But they're kind of different in the way they represent the questions, and that's how I personally like to do them. Right, so the main topic of today is looking at range changes, and we can identify that as when theta has a scalar quantity to it. So it could be half, it could be 3, and I'm going to just show you how to deal with it basically. So the first thing you need to write down is the new range that we're looking at. So new range originally was between 0 and 360, and our final answer will also be between 0 and 360 because that is the question. But to get this, we need to look at the range for 3 theta. So just like with all compound inequalities, we just do the same to every part of it. So that's still going to be 0, but 360 times 3, I don't want to embarrass myself, so I'm going to actually type this in on my calculator. Maybe just embarrass myself by saying that out loud, I'm not sure. but we're going to look at that range there. Okay, so just go back to normal basically. So cast. The cosine ratio is given positive values, so cosine's positive there and there. If we use our calculator, and I'm just going to, yeah, mine's in the right mode. So shift cos of 0.766, we get 40. This is the one it's given me on the calculator, it's the first one. And this is also 40. Okay, so we're going to have to go round for this range. So we're saying 3 theta is going to be 40. Remember, this is 0 and 180. Then we've got 40 short, or 40 shy of 360, so we're going to have 320. Then from 360, we've got to keep going around 3 times. So that's going to be up to 400. So this is now 720, so we're going to have 680. Now 720 plus another 40, we've gone 760, and our third lap is going to be 40 short of that. So I'm just going to put this down here, 1040. Pop a little degree sign on each of these. So there are 1, 2, 3, 4, 5, 6 solutions to this problem for 3 theta. But we want only values for our final answer for theta between these. So how do we get from 3 theta to theta? Well, you just divide everything by 3. So it's 40 over 3, 320 over 3, 400 over 3. You get the gist, okay? Now you could work these out, but you'll be really inaccurate. Why not just write an exact answer like I'm doing, and then there you have it. Okay, so let's have a look at a few more of these. Right, so this one we have to use an identity as well because we haven't got a single trig ratio. Now these aren't being squared, so it's the tan one. So if I can divide everything by cos 2 theta, right, so every side by cos 2 theta, I'm going to get 2 tan 2 theta, because remember tan theta is identically equal to sine theta over cos theta, and as long as that angle is the same, it doesn't really matter the fact that there's a scalar, a stretch, and that's equal to 1. So tan 2 theta is equal to a half. Okay, so let's draw a cast diagram. We know tan values are positive, so they're all positive there, and tan's only positive there. So I don't know how you've got a little double line there. Let's work that out. So shift tan 0.5 is equal to 26.6. So 26.6. Wow, something funny is going on here. So just going to get rid of that other line, that's annoying. So 26.6, and I'm going to put that in here as well, 26.6. Right, but we have to go and look at a new range because we've got this range change, this stretch in the theta axis, or the theta values being halved. So we don't have to worry about drawing the transformation of the graph, we can just change it on our cast diagram and then basically undo it. So we're going to go from 2 theta up to 720 in as low as 0. So that therefore 2 theta is equal to 26.6, and then we can add 180 to that, so we get 206.6. This is, I'm always write these to one decimal place, and then we have to add that to 360 because we're going around twice, so that's going to be 386.6. And what is that? That's 540, isn't it? So we get 566.6. Now what we need to do is divide all of these by 2, and as that last one was on my calculator there, I'm going to start with that one. So I'm going to just leave these spaces and just go for 283.3. That one's okay, 13.3. 103.3. I don't want to mess that one up, so I'm going to actually type it in. Some of you will be tutting at me, but I don't really care. It's all about getting things right at the end of the day. Right, there you have it. So that's one with a slight trig identity as well. So this is a slightly different range change, so we'll definitely do this one. And it's a single ratio, so we don't have to manipulate anything. So let's just go for it. Cast diagram. Here we can see the sign values are negative, so they're negative there and there. Now, if I put in inverse sine of minus 1 over root 2, or minus root 2 over 2, if you rationalize the denominator, I'm expecting to get a negative value, but I'm going to ignore it because it's down here. So, inverse sine, root 2 over 2. Actually, I'm not going to type that in. I'm going to use the fraction button. Okay, so 1 over root 2. Just put a minus in front of that. And you get 45 degrees. You actually get minus 45, but like I just said, we're going to ignore that. Right, so the new range is 2x plus 60. So we're going to double everything and add 60. So this one's going to be 60. So 720 add 60 is 780. Right, so let's just work this out. So 2x plus 60, what values do we get? Right, so we get none in the first 180, but we get one at 225. Then we get another one at 315. So we're going to go twice round and then a little bit more. So on our second journey, that's 540. So we're going to have 585. Obviously, we're at 720 here. So what is that? 675? I'm just going to, yeah, it's got to be it, isn't it? Yep. Right, but we've got to go to 780. Well, that's 90 degrees, and that we only needed to go 60 past, so you can see there's nothing else to report. Right, so all you've got to do basically is take away 60 and then divide everything by 2. So I don't know why I started from the back again there. So that's 307.5. 585, take away 60, divided by 2. 262.5. It's always nice to write them in numerical order as well. Oops. 127.5. 225, take away 60, equals divided by 2. Please don't type 225, take away 60, divided by 2 without hitting the equals button in between or using the fraction button, because you'll actually divide the 60 by 2 and you'll just be taking away 30. You'll get a very different answer to me. Alright, so it's a slightly different range change that's worth looking at. Now, these ones really be careful of. Right. This often fools a lot of people because, well, I'm going to show you how to do it. So let's start as normal. So we don't need to do this one. It's the same. So cast. Now the tan values are negative, so they're negative for tan there and there. So these are the angles we're interested in. And if we do shift tan of -1, we get 45 again. So I'm going to put 45 and 45. Right. So new range. So I'm going to take this slow. So theta is at the moment up to inclusive of 360 and more than or including 0. Well, minus theta would actually be minus 360 up to 0. Okay? But we've also got 45 being added on. So 45 minus theta means we're going to go as far down or far as up as 45 and as low as 315. And lots of people get that part wrong and end up messing it up. So we're actually going to go as far as 45 degrees, and you can see there aren't any solutions for that part. Now we're also going to go round, let's just write this down, 45 minus theta equals. We're going to go as far as 315, so not a whole turn. So let's have a look. So we've got one at minus 45. and there's minus 180, so that's minus 225. And then when we go past all the way to minus 360, you can see there's only two answers. So, what must this be? So we still need to work out theta. So 45 minus theta is equal to minus 45. So that must be 90. And so 45 minus theta is equal to this one. So what is that? 270. Okay. So there's my two solutions. Just rearrange that to make theta the subject, and you have it. Okay, so be really careful when the minus theta is in there. You've just got to take your time, because otherwise I see lots of people messing up this stage here. Now I believe that is it. So hopefully you're feeling as good as these guys, if not now, by the end of it. And you want to dance too. Whoop, whoop.